Alright, let's continue on with finishing off drawing automation. So where we had left off was getting our general dimension tool set up and working. So what I'd like to get finished in this video is we'd like to be able to go and get the rest of our dimensions working. So we'd like to be able to come in, like on this part specifically, it'd be nice to go here, and be able to create all of our diameter dimensions and get stuff like that working. So let's get that going. And then I think after we finish up this, and we'll try to include the Ordinate Dimensions too in this set, is we'll start working on actually creating drawings. But let's get the dimensions done. It's where we'll spend the most of our time when you automate drawings. So I'd like to try to make this as efficient as possible. And maybe even try to get the annotations done, some of the basic annotations working, like get center marks placed. So let's go and get started. So we'll just grab these and get rid of those. Alright, so we're in the wrapper again. So we left off where we're able to create a general dimension. So let's go into our curves object again. Okay, so we have our curves object. We can grab all the points. So and he has an association back to all the curves that exist in those points. So I'm going to say let's go and close everything out but this. That worked out good for us. Okay, let's go back to our extension methods. So since geometry point knows about its source curve, we can add some additional filtering. So like it'd be nice to know if we're dealing with circular curves or arc curves. So let's add a filter method in real quick. So we'll say public static list geometry point, and we'll say circular curves. So I think on let's rephrase this a bit. So primarily when we're dealing with circles, majority of the time we're going to be really interested in their center points for dimensioning holes. So let's go and make this one focused on that. So we'll say get center points. Okay, so now we've got that going, what we're going to say so we're going to get the center points from the circular curves in the list. So we're going to say, again, this is going to extend this dot list geometry point points. And let's think about this before we go too far. So maybe it'd be good to have like a filter here. So yeah, so let's think about that. So we have our curves object. So it'd be nice just to return. So maybe we add it here too. We'll add something here. So we'll say public list of Inventor drawing curve. So circular curves. So we're going to say return this dot where curve dot curve dot curve type equals circular curve. So this will be a quick way to only get the circular curves out. So let's start with that. So get the circular curves from the list. And if you look, we can, and maybe it'd even be better to like pass in a filter. So we could say, let's see. So curve types. So we'll say where curve type equals so that's a good one to have. I think we'll also want the circular curves though. So let's go ahead and do that too, just as a quick shortcut. So we'll say public list, Inventor, drawing curve, get. And we'll just say return, get curves by type. And we'll say curve type dot circular curve. And I know this probably seems a little redundant to do this, but I do want to reiterate with drawing type code. If you haven't had to do it before, it can be very, very tedious, and there is a lot of it. So anything you can do to save yourself a couple lines does add up really quickly. So we want to try to make sure that we're writing as little production code as we can, and try to single it out two methods that we've had well tested. So I'm going to continue along. I think this is the right way to go about this. So now that we've got that, so it'd be nice to say, so I wonder, as part of this, so let's take a look at our curve object real quick. Yeah, let's go put our curve object. I think okay. So I do think that would be really nice to know what type of point we created. So let's go and add that in. And I do think, okay, so while we're thinking about that, I think it'll be best to separate that out because we don't want to grab midpoints. We're looking for center points of circles. So let's go and do that. We'll go geometry point, midpoint. And we'll say if curve dot midpoint equals null, Okay, so now we'll do the same thing here. So we'll just so let's add that in now. So what I think be best to do is we'll go into the drawing and we'll go into the enums, and let's also add another class. We're going to call this point type. So we're going to say public enum point type, and so let's so now we got that. So let's take a look at what we have. So let's put this over here. All right, so and let's go and write all these out. We'll say so as far as start point, end point, I don't think we're ever going to be too worried about which one's which. And there's not a lot of consistency I've found between which one's the start point, which one's the end point with Inventor. Sometimes it depends on how it draws the curve. So I wouldn't get over focused on that. So I think we'll just go ahead and say, because I think we'd be interested to grab either of them in that case. So we'll just say, let's just call it endpoint just for logic. So our first type, or first one will be endpoint. And then we'll go with top left point. Then we'll go bottom left point. And we'll go bottom right point. And then we'll be interested in the center point and the midpoint. Okay, so now let's go and add that to our geometry point object. So when we construct it, we want to know what type of point it is. So let's go and add that in. So we'll say point type, and we'll say point type, and we'll go and set that. And what did it go and duplicate this? And add that to our XML docs. Okay, so alright, so now let's go and finish this up over here. Okay, so now we're gonna go and add this in now. And we'll say this is a endpoint. This is a endpoint. This is a top left point. Top right point. Bottom left point. And a bottom right point. This is a center point. And this is a middle point. Alright. Awesome. So let's take advantage of that now. So now that we have some additional filtering, so what we can do now is we can say return points dot where point dot point we made a small boo-boo here. So let's fix that real quick. So we actually want to go we're going to change this to point type. Now we're going to change this to a get private set. There we go. So this dot point type equals center point dot toList. Alright, so now we've got some pretty decent filtering now to go through and find what we need. So that gets our center points nice and neatly. So, and we've got the ability to get any type of curves that we need. Okay, so what I'd like to do now is we got our curves. So let's go back to our drawing view object. So we've got our add general dimension. So let's go and add a Ordinate Dim tool. Okay, so let's add this real quick. So we'll say public void ordinate. We'll say add ordinate dimension. Okay, so in this time we'll be interested in a list of geometry points. And well, the same thing. We need to know the dimension. Yep, the Inventor dimension type. We'll need to know the side. And we'll do the adjustment as well. All right. And we'll say add a ordinate dimension set to the view. Okay, so let's take a look. So let's take a look at what do we have to do to make this work. So let's take a look at the documentation again. So if we look for our sheet object, okay, so let's see here. All right, so drawing dimensions. So now we're going to go into here and we're going to say ordinate dimensions, create ordinate dimension. So yeah, let's start here with this VBA code. So let's get an idea of what we need to do. So we're going to, and also, this is also a good reference to get you an idea of how much work we'd have to do without the wrapper just to make a simple dimension. So I hope this helps kind of get an idea of how much work we're saving by writing this. So let's get started and kind of look at what our main thing. So we have the geometry intent we're creating, and now we're setting a reference to the view. Okay, and what I probably wanted to highlight was where is that? I don't see the example here like I wanted to show. Let's go back. So let's just go into the documentation and add. Okay, so we say the input geometry then specifies the geometry dimension. Oh, you know what? Let's go back one. We went to the wrong one. We want the sets. Ah, okay. This is why I wasn't seeing the example I wanted to show. So they don't have a good VBA example. So here is a special type called object collection that they've built. So it's a collection of geometry intent objects. So the first object in the collection is assumed to be the origin. So that's going to be important to remember. And I always recommend when you're creating ordinate dimensions, if you can have them pre-sorted, it will make your life a bit easier. You can go back and find them later. But if you're having, if you want your origin to not be the very left point or the very right point or, so forth and so on, get that sorting set up before. Okay, so, and then we want to know, this is going to be our text location again, and the type. And it's also important to remember that there's less variety of dimension types that are valid for ordinate. So what will likely happen, and we can test this, is you'll generally probably get an error if it doesn't match one of these three main types. And again, we can change styles. Again, this is probably best to set in your template, but if you needed to change it, you could. So let's kind of get started with this object collection. So let's see what do we have to do to use it. So we were going to add an object to the generic collection. So you see it's kind of a mess how it's created. So it'd be nice to know. So I was hoping to see a good example of just how to create one. So I do know where it's located at. So let's go into the transient objects. So again, the transient object is that one we used earlier. Well, we used it before. We used the transient geometry before. Let's go to transient objects. So we're going to see create object collection. So this is the one that allows us to create that enumerator that we can use to pass back to Inventor. So let's get started with getting that implemented. So we're going to say object collection, and we'll say collection equals inventor.application transient so what we can also do here is Inventor we actually access the source Inventor transient objects create object collection. So let's go and make a shortcut for that because we'd rather not have to do that. So let's go into here. Okay, so let's go and say public static transient objects. Oh, in this case, transient objects dot get transit Okay, so now we've got that set up a bit nicer now. Let's go back into our view. And let's just say, okay, so now we've got that. So now let's add our things in. So we can see kind of, let's go in. I wanted to show the source object for that real quick while we're here. It's just implementing IEnumerable. So again, we're kind of running into issues against actually running our tooling against it. So let's go back into that. So you'll see again, that's we can do count and do all the stuff we'd like to do, but we can't run the link against it, which is a big pain. Yeah, so we're gonna just go and make a temp object to hold these in for us. So we're gonna say for each var p in points. We're gonna say collection dot add p dot create intent. Okay, so now we've got that going. So now we need to go and create our dimension. So let's go say, we're going to say var, we're going to say, okay, let's go sheet dot drawing dimensions dot ordinate dimension sets dot add, and we're going to say collection, and we're going to say oh, and it's also at we're going to need to use our same method that we used over here to help us out. So we'll use the so he'll go and help us out and create that point where our and we'll say the type of dimension. Okay, so then let's go and add that in real quick. We'll say create point. All right, and now we're good to go. So we should be able to create an ordinate dimension now. So let's add in one more. I think we probably shouldn't make this one optional. We'll leave it as optional. Because I think most people tend to do this. Let me know if I'm wrong, but I think most people tend to do this. All right, awesome. So we'll say var dim, and we'll say dim dot continuous running equals true equals continuous running. Yeah, I do think that most people tend to do that. I'm sure there's some that don't, but we'll leave it as a optional parameter. And all right, so let's test that out real quick. I'd like to see how that's going to work. I think everything's fine there. So let's go and open up our test project again. Okay, and let's get Inventor off to the side. Alright, so let's get rid of pretty much. We'll just leave those. So we've got our points now, so let's leave the top left and the bottom left. And then we say, well, let's get the, instead of that, let's do var top right point equals points dot max x points dot max y point. Okay, so now let's go and get the center point dimensions. So var center points equals points dot get center points. Okay, and now let's create a collection of those. So we're going to say var ord dim points equals top left point. So we'll say new list of geometry point. We'll need to import that in. And we'll say or dim points dot add top left point or dim points dot add top right point and or dim points dot add range center points. Okay, and now we're going to say view dot add ordinate dimension set, and we're going to pass in our or dim points. And we're going to say this is a horizontal dimension type, and we're going to say this is on the top. Yeah, I mean, either way is fine. I don't really have any real opinions on using object initializer or just hitting add. I leave that up to other people to have that particular argument. It'd be nice to know. It'd be nice for them to have like the spread operator, like TypeScript does in the future, where we could just throw in these points too. But you know, it's not currently possible. So we'll just move on. So let's go ahead and run this real quick, and I think we should be good to go in the first try. I don't think I made any serious mistakes. But, you know, that's part of the fun of programming, is to see what you made a mistake on. Well, huzzah, look at that. Works first time. So, that looks pretty good. I'm pretty happy with that. So, let's go and... And if we were going to make this for a company, so let's go and add our other ordinate dimension real quick. Now we've got that running nicely. So we've already collected our center points. So let's go and add one right here. We'll say var bottom left point equals points dot min x points dot min. Oh, sorry, my bad. Dot min x points dot min y point. And I wonder if it'd be just worth, because we'll be writing this quite a bit. So I wonder if it would just be good to add that to our own extension methods as a shortcut. I think so. I don't have any real reasons why we shouldn't. So let's do that real quick. Let's go into our... So let's add that in real quick. So we're going to say... Well, you know what? Yeah, let's go and add it in. Public geometry point. So get max x max y point. And we're going to say that returns, I'll say this dot list of geometry points, and we're going to say that returns points dot get max x points dot get, oh man, I am all over the place with typing today. So get dot max x points dot max y point. So that's a kind of a, so don't really have any real issue with that. So, I don't think that's going to be particularly inefficient. Because I think, so say if we had just went and written this out, we'd have to go and repeat this core logic anyway to go and find those. So, I say we just stick with it. I'm pretty happy with that overall. And that'll make us a shortcut for that, so we're not constantly typing that in over and over again. So, let's go and finish that off real quick. And if this ends up becoming a performance issue later, we'll go and fix it. I don't think it will. Points dot max x points dot min y point. And we're going to say public static geometry point dot get min x point max y point. This dot list of geometry point, and we're going to say, well, how about we finish that off first? We'll say points dot get dot min x points dot max y point. Public static geometry point. And we'll say get min x point, min y point. And we'll say this dot list of geometry point. And we'll say points dot min x points dot min y point. Okay, there you go. Pretty happy with that overall. Yeah, no complaints there. We'll do some more testing to make sure this is truly going to be what we wanted. But I think that'll save a little bit of code. And then this is just giving us shortcuts, and we're just reusing the same logic, so we're not having to duplicate code. So I'm pretty happy with that overall. So let's go back into that window. And so let's go and say, this will cut out a little bit of code for us. So let's go and see how that, if we feel like that, how we feel about that. We're going to say the max x. Well, I don't. Okay, let's fix that though. I don't want to change the naming convention though. So let's get rid of that get. All right. Yeah, just personal preference. I would just like to have a consistent naming for those. Well, yeah, let's keep it the same. All right, awesome. So let's go back into our main window, and we'll fix that. So it's our get max x, get max y point, and we're going to say the same thing here. We're going to say get max x point, max y point. Well, actually, we need to fix that one. That one should be min x. Okay, and now our bottom left will be dot min x, min y. Okay, so now that's set. So let's go ahead and create. So this is going to be a. So let's rename this real quick. We're going to refactor it, and we're going to call this top dim points. All right, so let's create a var left dim points. In this case, we're going to be interested in the top left point and the bottom left point. And we are going to do the same thing, left dim points dot add range center points. Okay, and now we're going to go and say view dot add ordinate dimension set left dim points, and we're going to say this is going to be a vertical dimension, and we're going to go on the left. Let's get rid of that. Okay, play. All right, pretty happy. So one thing that's not the Inventor does that's nice is it goes and filters out duplicate points around ordinate dimensions. So if we wanted to be really prim and proper, we probably should have removed the rightmost center point from that collection, but we don't necessarily have to. Maybe it's probably best practice too, but in this case we didn't. So let's add in the last thing that we'd like to do to finish off a simple drawing like this is we'd like to add center points for those holes, and we'd like to add a dimension for the diameter of that hole. So how about we start, let's start with the diameter dim. So let's see. So let's get a quick idea. So one thing we want to know about diameter dims, we all know, is that they tend to be at an angle and kind of going away from it. So we want to be able to, so when we pass this in, we need to say, what are we dimensioning? And where do we want the text at? So it's not going to be quite as simple as the other ones were. So we'll probably do something simple like keep it at a 45, but we can have a different adjustment to shove it out. But I think kind of have at a nice angle like that, or we definitely don't want it straight out of this. Generally, they're about something like this. So let's go ahead and start making some tools for that. All right, so let's go into that real quick. And let's clean up our screen. So let's close the XAML screen and bring this over here. And we're going to close tabs to the right. Okay. And we might make that private for now. I don't think it'll be accessed outside of this class. Okay, so let's go public void add diameter dim. Okay, so and we're only ever going to have just one point, so we'll say geometry point, and we'll stick with our point just because we have access to the curve, so in case we need that for what we're trying to do. So and let's say what side I think the view side still be important. And yeah. And we probably need a little bit more control over our adjustments. We're going to say double X adjust equals 1 and double y adjust equals 1. Okay. So okay. So let me think. So so we have some options. We can overload it. Yeah. So let's add another. I think since we're gonna have two adjustments, let's add a secondary method that'll help us out. Okay, so let's say we'll add another one. Just we'll add right below, just for clarity. We'll say, say drawing diameter dim text locator. We'll just stay with that for now. And we'll say that returns a point. And we'll say, let's go ahead and do the same thing we did before. We'll say double x equals 0. Oh, my bad. And we'll say if view side I wonder what is going to be the best thing to do here. Is should we just should we even be worried about view side on this one? I mean, I think we should. Let's hold off on this one. Let's see. Let's just say return not new not implemented exception. Okay. So let's go ahead and say now we're going to say, let's go var diameter dim equals sheet dot drawing dimensions dot general dimensions dot add diameter, and we're going to say we're going to look at our, so we're interested in location of our text first. So we'll say new point, and we'll base that point off the we'll say it's based on our point dot x plus x adjust, and our point dot y adjust. Oops. And we'll say we need 1. And then we need to do point dot create intent. Okay, so let's start off with that and see how it goes for us. And thanks for. Okay, so I think that'll handle what we're wanting to do here. So let's go and test that out real quick. So let's say we want to put this dimension on the right side. So we're going to say var right hole equals center points dot center points dot get. So we'll get the dot max x point. So that'll give us the right hole. And now we're going to say view dot add diameter dim, and we're going to say right hole, and let's do, we haven't really implemented that, and we're just going to say we're going to go 1, and let's go -1. And I think that will do as a concept. And all right, so not too shabby. So definitely not very clean. So let's see if we can make that a bit better. So let's add a bit more to the adjustment on that, and we'll say 3. Well, not perfect by any means still. Let's think. So we're grabbing that center point. So I wonder, in this case, it'd be better just to have an operator against the curve. And I think that's what we need to do. Let me see. All right, so what I'm thinking is maybe, yeah, so maybe we need to focus on the curve itself here instead of the point. Okay, so, hmm, so just for curiosity, yeah, so let's focus on the curve and get that value out of that curve, and I think that'll get the dimension where we want it at versus trying to focus on the center point. So let's close this real quick. So we have our curves, and so we do have, so we got our right hole, which is a geometry and point that does have a reference back to its curve. So let's say we're interested in this, so right hole dot, well, let's go look at our geometry intent object. What do we need to do to make this work? Okay, there's our curve. So yeah, let's make that public. There's no reason to hide that away. Okay. All right, so let's go back to that now. We're going to say right hole dot curve dot. So now we have all these points we can work with. So let's say we're looking for the, so we have the top right point and the bottom left point. So for us, those are useful. I think we're going to need a couple more though. So we'd be really interested to know on a circle like the point where the square intersects at, you know, the midpoint here, all these vertex points. So let's go into our curve object real quick. All right, so let's maximize this. Okay, so we have all of these points we've went through and created. So let's get our vertex points set up. So we have top left, top right, bottom left, bottom right. So let's go and add this and we'll say public geometry and point. We're going to say right midpoint. I think that makes sense. We'll think. And we're going to say this is equal to the range box dot. So I wonder. Yeah, let's keep it simple. We're just going to say we're going to go to range box dot max x point dot x. So this will be in the max, so we can just do that. And we're going to say range box dot min y point dot y. So that would be the same as the bottom right. So what we need to do is go up from the difference between the max and the, so we're going to say range box dot max point dot y. Okay, so now we're going to say, now we want the difference between those and half. So what we're going to say now is Whoa. Man, sorry, I'm overthinking this. So we're just going to end up going, and we're going to subtract. I think that's what we want to do. I think I'm really just overthinking this. Oh, no, I'm underthinking it. Okay, so let's go and say, so we're going to be looking at the max point. And we're going to say dot range box dot. Okay. Dot divided by 2. And we're going to say this dot. So in this case, this is a vertex point. What is for now? Let's just go to point type, and this one was added as a vertex point for now. Vertex point. Okay. And there we go. I think that's pretty much what we're after. Vertex point or circular. Let's see, we'll go max x vertex point of a circular curve. All right, so I think that is the money right there. So we're going to type out this section here a little bit. So let's go and write a quick little helper function. Private double. I will just say mid x. And we're going to say this is equal to range box dot max point dot x minus range box dot max point dot x minus range box dot min point dot x divided by 2, and private double mid y equals range box dot max point dot y minus range box dot max point dot y range point dot min point dot y. I almost feel like I lied to you guys a little bit when we started this. Now that I told you the math would be kind of light, but unfortunately, drawings there's going to be a little bit of math. Get the midpoint of the curve, the mid x value of the curve's range box. Gets the mid y value of the curve's range box. It's kind of funny, like when you start looking at math stuff about any questions you have, you start getting advertisements for math classes. So I guess everything's targeted for you. So there's that solved out. So let's go and use that now. So, and we're going to say that is yeah, so we can shorten that up a bit. So we're going to say that's going to be mid y. All right, awesome. So let's copy that 4 times. And we'll say top mid, left mid, bottom mid. All right, so now we got our top mids, so we're interested in this time it's going to be range box dot max point dot y, and this time it'll be mid x. Okay, this is the left midpoint, so this will be equivalent to the right mid. So in this case, we're going to be interested in the midpoint x, yeah. And same thing here, we're going to be interested in the bottom mid, so we're going to be interested in the mid x, and we're going to say it's going to be equal to the range box dot midpoint dot y. Okay, so there we go. So let's go back to this now. So now we should be able to say that we're going to be able to grab the right holes, curve dot, and let's say we're going to be after the dot bottom midpoint. Okay, let's test that out real quick, and I think we are good to go now. Awesome. There we go. So that is working the way we want it to now. So this is a little verbose still. We'll work on ways to maybe condense this a bit, and if you guys have any ideas, feel free to leave it in the comments or post it on GitHub. I'm always working on making this better, so this is a process I've been perfecting for a couple years now, and been slowly improving over time. So I think this is a pretty good solution. I know this is an unfortunate amount of code for what we've done, but it's important. There's a lot of work to automating and drawing, so and this doesn't just apply to drawing automation code. If you've ever worked in enterprise development, you know enterprise. You could imagine automating anybody's workflow is there's a lot of steps to it, and detailing a drawing there's a lot of steps because you imagine your detailers have to go through here and click all these and dimension it. We're having to duplicate all this, and even though we've tried to condense it as much as we can, there's still a lot of work that goes into this. Could you imagine when a detailer goes and dimensions it, he needs to select all these points. So we had to go through that as well too. So I think take that in perspective that unfortunately there's not going to be any huge shortcuts, but we can come through with some more additional automation. And especially if your particular workflow has extremely common parts, you can set up some base classes for yourself when you implement the wrapper code that'll go through and automatically dimension certain parts and holes and features for you. So this is a pretty good stopping point for the day. I think when we resume, we'll finish off some more annotations and get the center points done. All right, thanks for watching.